Hi, in this video, we are going to take a look at the differences between OLTP and OLAP designs. OLTP designs are for transaction processing and represent the typical type of database that people work on a regular basis. OLAP or data warehouse two style databases are becoming more and more common and are used for reporting purposes. First of all, let's take a look at typical design for a transaction processing database. You typically see normalizations being used, so the idea would be that you want to reduce the number of redundant values. So I might say something like this. I've got a stores table down here, and in the stores table, I have a state ID column. Now the state ID column links over to the states table. We would have taken the state's name and put it right in the stores table instead of the state ID like this. But at that point, we would have also had to add the abbreviation. So what have happened is that every time there was a same store in the same state, not only would the name come over, but also the abbreviation would also be there as well, meaning that it would be repeated values. So in normalization, instead of having a bunch of repeated columns, you end up reducing things by using a repeated ID. Here is state ID, and a separate table hold the data. That's just one part of normalization, but certainly one of the major hallmarks that you see on a regular basis. Now, the line items. When we see the sales line items, we see that it's identified by the sales ID and line item ID. So the line items represent a different granularity for the table. We typically use the term granularity when we're dealing with the data warehouse. It's also true in an OLTP environment. In other words, the detail in the sales line items table has to do not just the sales ID, but the line items. Look at the sales table, it's just identified by the sales ID. That means the two tables have different granularities, and the granularity plays an important part when we go to design the fact table and our data warehouses. And look at the employee table. We see a parent-child relationship between the managers and the employees. So one manager can have many employees, and although the one employee can have many managers. One thing about the employees table is that the levels of the employees and their particular managers could go to levels down, like 3 levels down, 4 levels down, or 5 levels down. Let's take a look at an example. Let's say we have a manager who's the top manager and his name is Bob. Bob has an employee named Sue. That works, right? But Sue also has a co-worker named Tim. Tim reports to Sue. And then we have 3 levels down. Now there's another one named Jeff, and Jeff reported directly to Bob, the guy at the top. So that means Jeff and Sue are at the same level. Bob's at the top, Jeff and Sue at the second, and Tim was on the third level. Now we have 3 different levels, But if we get a new employee that reports to team, reports to team, the new employee, now we have four and so on. So in a parent-child relationship, the relationship can easily be represented by just matching a managerial ID or reports to as it sees in some database. And the employee that is with these forms, they are refers to as a ragged or jagged hierarchy. The hallmark of this is the fact that it is unknown how many levels deep it goes. And so you do end up with a parent-child relationship. Another thing to note is that the line item table represents a bridge between the sales and the title. So it also named as defines what's known as a many-to-many relationships. A many-to-many relationship is very common in OLTP designs. Here's an example. There's another example which could find from this design. The one author can write many titles. To associate a set of authors to a set of titles, we can use a bridge which names title authors. It can combines to by creating two columns, a title ID and an author ID. Then it's gonna link the two tables together. The same is true as sales line items and sale line items. What you end up having a bridge between the sales table and the titles table. It's true that one sale can contain many titles, but one title hopefully will be sold many times. So that means we have two many-to-many relationships to find here. So we see a standard set of tables with being normalized between stores and states. We see parent-child relationship, employees, and we see a relationship where we've broken down into the normalized things with line items. So when you're building up a data warehouse, one of the things you end up doing is you end up flattening things to make them simpler to use. It's true that you can actually design a data warehouse that is more than what they call normalized, but there are a number of thoughts against that. Specifically, it violates the rule of simplicity. When you are making a data warehouse, you want people to be able to make reports against it as simply as possible. Let's contract an OLAP design and OLTP design. So the left-hand side of the panel to see is the standard yard design and the one we just reviewed. I'll minimize the data type so you can just see the column name. The right hand side you see is a data warehouse that would be derived from those set of data of tables. A few things to note: the sales table have been collapsed into a single table. You typically will change that name from just the sales to like fact sales or sales fact. So personally, I like to put the definition of what tables utilized for in the front. In the tree view, when you have a whole bunch of tables, it can help you have all the tables grouped together by their depths that use such as dimensions or facts. So the two sales tables clap into a single sales table. And then we have the things that we wish to calculate, such as I like to be able to calculate the sales quantity and the actual sales price. I might, I might want to know overall what was the sales quantity based on a particular title. What was the actual price over time? So I could take the sales price over time on a given title for a given day, and as such, the items that I wish to calculate as measures. So in the fact table, I would see things like the sales quantities and the sales actual price. Then I would have IDs that would describe the sales quantity for what store, for which employee, for which title ID, for which state, and perhaps even the sales line items or sales ID. So later on, we will take a look at the fact tables and dimension design in the following videos.